Okay, well, I think we should be live here. So I'm going to go ahead and get started. I just want to thank everybody for coming out today. We're going to try to make this interactive. I mean, I'm not here to give a presentation and just try to be a professor and talk for the whole hour. If anybody, there's people in the room that are going to be smarter than me about things. There's people in the room that are going to have less experience with things. And so if anybody, if you think I'm saying something wrong or I'm saying something that needs to be added to, then just don't hesitate to put your hand up and contribute. Because we are trying to broadcast this as a Hangout and then also have it available for people to watch later, I would ask that if you're going to get into an extended question, try to keep your question concise or your statement concise so that I can kind of repeat it. Because I'm closer to the microphone here, I don't think that this is going to pick up what people are saying from further back. Are you on there? Yeah, cool, yeah. Yeah, oh, is that what's showing up right now? Cool, thanks. Yeah, I'm going to actually share the slides in just a second here, but that's it right there, cool. Yep. In fact, thanks for reminding me. Let me just bring this up on my second little monitor here effectively so I can keep an eye on what's going on. In fact, let me just share the slides. Does anybody have any questions or anything that they want to throw in for now? Okay, cool. Not seeing anybody jumping up and down to talk at this point. So we're going to be going through these slides that I prepared. And can I just get I don't want to go around and do introductions because it just takes too much time, even for a smaller group like this. We do have this Slack channel, so I'm going to do a couple of sort of quick polls here. And just try to do it very quickly because, like I said, anyone watching this later won't be able to see all of you. But does anybody use Slack? Like, are you familiar with Slack as part of your work? We've got a few people here. Okay, so for people that don't know, Slack is like a groupware tool. Like over the years, development groups have used things called like Jabber or IRC chat. If you're not familiar with working as a developer, nobody works alone anymore. Everybody's working in a group, and the better tools you have to communicate. Sometimes it helps and sometimes it doesn't, right? But I think Slack is pretty much the tool of choice these days. So if you think that you want to be part of this group continuing forward, a lot of people have joined the Slack room already, and I would suggest that you do that. I post things in the Slack room, like access to the files on GitHub that we are going to be using today. And I just want to go through some of these slides and come on now. Oh, there we go. And I will say right up front that I'm running Linux here, and Hangouts in Linux isn't as good as Hangouts in Windows. I mentioned this to people that showed up earlier, but if there's some glitches, just bear with me. We're mostly here, and who has actual experience like running a Jupyter Notebook or using Pandas? Like, are most people here? I'm seeing 3 hands go up. And so the people that didn't raise their hands, I'm thinking that's what this presentation today is more geared for. And then the people that did raise their hands, I'm depending on you to be helpful contributors. And if you think I'm not mentioning something that's useful, again, don't hesitate to jump in. And I think that we're all here to educate each other. And who actually works, like I don't work as a developer right now. I have in the past with Java and Apache Spark. So I'm into data science and machine learning, but I'm probably not as advanced as some of you sitting here. But who's actually working as a developer right now? We have 3 people in the room. That's very cool. 4 people. Okay, so you work at BYU, and cool. Okay, and he's also a student at BYU. Is anybody else a student at BYU or anywhere? Okay, cool. That's a good mix here. So Pandas is a great. And for you watching the meetup back there, am I broadcasting this properly? Or watching the Hangout? Yeah. Just if you can kind of. If you think that I'm like not showing the right thing on the screen, don't hesitate to pop up because I'm trying to juggle a couple things right now. But Pandas is a great program for people that have used it. Python, if you look at the progression of programming languages, you started out in the old days with C or C++. You had to manage memory locations. You had to do. You're looking good. Okay, thank you, sir. You had to do a lot of tasks that kind of take you away from the things that matter. I mean, you're ultimately trying to build a solution and not be so concerned with assigning pointers and releasing pointers. If anybody's ever worked with C or C++, you spend a lot of time just trying to avoid crashes and allocating memory manually. So then Java came along in the 90s, and Java's pretty much open source. It's owned by Sun, but obviously it became the workhorse of the industry. And it avoided having to manage memory, but it's still, if anyone's ever seen Java, I love Java. It's a great language, but it's still a little bit ugly and has a lot of overhead. So you find there's, sorry?
You should write Scala.
Yeah, well, Scala is really good. I like Scala. I actually, when I worked at Huntsman Cancer Institute, I was using Apache Spark, and my boss was sort of an old school Java and relational database guy. So he hates NoSQL databases, and he hates any language he's not familiar with. And he's a great guy otherwise, he's brilliant. But he wouldn't let me write in Scala because he didn't want to maintain something when I left. And but you find what's happening is you've got this convergence. You know, there's people that are just straight computer science students, or computer science people, which is great. But you're seeing the whole thing about data science is that people who have specializations in areas like chemical engineering or physics or mathematics or any other research area, they need tools to be able to come in and do data processing. They don't want to depend so much on a computer science person themselves. So you're getting these higher and higher level abstractions of programming languages like Python. And then Python has led to Ruby, and I think if I'm not mistaken, Erlang comes out of Ruby. There's a pretty cool Erlang group around here. But basically, Python has become, in the commercial world, the language of choice for doing data science. In the academic and research world, and especially in the biological world, it's R. And I don't know if anybody has used R in here. I don't like it. Having come from C++ and Java, R just seems like a great statistical package. And then I think somebody said they had experience with SAS and SPSS. I forget who that was, but those aren't things we're talking about today. But R is great. We might do a presentation on it. That's more in the academic world, in my experience. If you're looking for a data science job in the corporate world, you have to know Python. Like, that's just the #1 thing, in my opinion. I don't think there's any language or package out there that is going to be more important to understand, right off the bat. And then Python has packages that are just ubiquitous, like Pandas and NumPy. So we're primarily here to look at Pandas today. If you look, you can look up the docs. To me, the main thing, and I'm going to just try to get through these slides pretty quickly here in the next 10 minutes, and then we'll jump into the actual examples. So what I've done with these slides, they're not graphically beautiful. I'm not a graphic artist. That's like the last thing I want to be. And is anybody in here a graphic artist? Good. I'm not going to offend anybody then. I don't like working with graphic artists. It's a personal failing of mine, but I have great difficulty working with graphics people. So if anybody thinks the slides need to be more beautiful, you're welcome to design something better. But the main reason I put this, okay, so my little bias against graphics people just came out, and aside from that, I won't mention it. But the main reason I put these slides together is as a resource. If I talk about something and you're at that point where you're still trying to figure all this stuff out, you can go through and get links. For example, Pandas, so just to give the basic overview, Pandas is a package in Python. It's actually written for the most part in C. So if you were to try to do something on your own and create a data structure in Python using lists, and who has Python experience in here? Who knows what lists and dictionaries are? Okay, so we're still largely dealing with people that are getting introduced to the language. So Python, I'll just take a minute to explain. Python has its own built-in data structures. There's lists, there's dictionaries, there's different ways. It's an object-oriented language. You can write classes. You can do pretty much everything. I'm sure a C++ person would disagree. But for a data science standpoint, you can do everything you need to in Python. But Pandas itself is often written in C, so that when you run something in Pandas, it's way more efficient than what you could write yourself in Python. So that's the #1 reason to use Pandas. It's going to, instead of trying to write data structures yourself and write statistical routines yourself, a lot of the stuff is already built in. If you want to take the mean of some data, we'll look at the example later, but you would just bring the data into a Pandas data frame and just run the mean function on it. You don't have to invent everything from scratch. So again, for people that are just trying to get their hands around this stuff, this is why it's so important to know these things, and there's great documentation. I'll show you this. Let me see. Let me just take just a second to actually, I know I got you back there watching the Hangout, but let me just bring it up here so I can kind of see it without having to bug you. I want to make sure this new window just came up. Sorry, I guess they say it's not showing. Oh, it's because okay. Oh, I see what's going on. Yeah, let me think of how to do this a little better. Well, I'm just gonna go over here. You know what? The people at home, I don't think anybody's actually watching at home right now, so I can add some notes in later. But for the people here, I just want to keep this moving. So, when you look at Pandas, Pandas has documentation, and this is where you need to spend a lot of time. To me, the biggest thing about figuring this stuff out, and the people here who work with this already can attest, you need to be able to teach yourself, right? Like, especially in a work situation, your boss doesn't want you bugging them all day long. How do I do this? If you don't have the ability to Google things and look on Stack Overflow and look in the Pandas documentation or even the Python documentation, then you need to really get better at that. So you'll find in the main thing I'm trying to show you here is that in this pandas.pydata.org, if you come to any of these documentation pages and look through this index here, there's a lot of great stuff. There's this intro to data structures. We'll show you. They show the import statements, they show how to set up a series. We'll look at some of these basic examples in about 5 or 10 minutes, but this is the kind of stuff that you need to be able to look up. There's a bunch of tutorials here. Bring this page up here. Oh, sorry. Okay, the tutorials are very helpful as well. If I can get them to come up here. Okay, so there's this thing called the cookbook. There's lessons right in here. So, again, if you walk out of this meeting today and you think this is something you really want to get some experience with, there's 2 different ways I would suggest you go about that. One is that you need to learn how to read this documentation. And then I would also really suggest, if you're in college, that's great. I don't know if BYU is teaching like specific data science classes yet. I think they have something like that, like more of a big data degree or something. But even on Coursera or any of the the MOOCs, the massively open online courses, like Coursera, Udacity, the woman here, I forget your name, I'm sorry. Lisa had mentioned, that she's done some Udacity courses online. I did a data science course at U of U that we'll look at an example from pretty soon here. And I got rusty. Like, if you don't touch this stuff every day, if you're like me, if you get away from programming for 3 months, you're in trouble, because when I get away from it for 3 months and I study operations management and lean management and things as well, and then I come back to programming and it's like, I'm really rusty, So I find that I'm actually going back through some Coursera. There's a series of courses called Intro to Data Science with Python. It's pretty basic stuff, but it's also good if you need to get your feet wet on this and understand. So, and again, after this hour, if there's people that want to look at any of those things, on the side, I'll be here till about 3:45 or 4 o'clock, so we can look at those. Now, there's a link right there to this Coursera course that I'm talking about. Let me actually just share this, because I'm going to keep going through. Sorry, bear with me for just. And if anybody has any questions at any point, just jump in or wants to contribute anything.
I have a question. If you're learning,
yeah.
So right now I'm learning Python.
Okay.
And from what I've been able to gather, it looks like people like R, it has better data visualization. But it seems like there might be a shift to just exclusively using Python.
Yeah. So the question is about Python versus R, and you specifically mentioned that R may have better data visualization. I think you get a serious argument about that from Python people. I think R, go ahead, please.
So I think the biggest difference is if you're not familiar with programming structures, R is a fantastic way to do it. If you're used to programming in Excel, R is fantastic.
Oh, okay.
If you're learning anything about programming structures and data structures and programming logic, Python will be R every time.
So the point being made is that if you're a programmer, Python's easier. And this is kind of the point I was making earlier, is that there's people who they're not mainline computer science people. Maybe you can meet some really brilliant PhDs that just don't know how to write a line of Python. And they're really brilliant people. They just haven't had the computer science background. So I think you're, and I didn't mean to say that I'm right and you're wrong. I mean to say that if you ask an R person, I think you'll get that answer. And I think I think you'll find that for Python though, and especially pandas, hey guys, how's it going? Come on. Especially for pandas, once you have some data in a data frame, you just refer to the data frame and say plot, and it comes up, there's some pretty easy options. But we could look at that. I mean, if you wanted to show,
Get a sense of what people buy.
yeah, I mean, does anybody else have an opinion on that? Does anybody have background with R? I mean,
So I use R often to just initially look at data.
Okay.
Like if I've got a big dumb data set and I want to just peruse it without writing a bunch of code, I use R every time.
Is that right? Okay.
Yeah. Because the tools and the commands for doing that inside of R are really simple and easy.
If you know R.
It doesn't take that long to learn R.
That's true.
Aren't that big. But if you're going to process the data,
Yeah.
if you can do stuff like that, you can do it in R, but you can do it faster with Python. Especially if you're going to do something with large data sets, Python is much faster than R.
That makes sense, yeah.
And so they've got hooks into Spark now for writing R code into it.
Let's say that again. You're talking about Spark?
I said they've got hooks into Spark now.
Yeah.
But
it's not as developed as PySpark.
No,
yeah.
No, but if you're using Spark and you really want performance, you write Scala.
Yeah, that's true, right, yeah. Although people like Python, right? If they don't know Java or Scala, then they're gonna. So I think the answer to your question is that it's probably partially true what you're saying and partially a matter of preference. I mean, I think the underlying question that you're asking about, R versus Python is what I was getting at before. In the academic world, I think you'll find that, I mean, Google uses R, right? So the R is out there in the corporate world, but I think most corporate people are going to be more coming from Python. Are you in a corporate environment, I assume?
Yeah.
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 Do you mind telling us where you work at, or?
I work for a company called PayClip.
Okay.
We're just like Square. We're a mobile credit card processor.
Okay, cool.
But we process in Latin America.
Okay, so I think there's probably no clean answer to your question, and it sounds like the guy that's got more experience with R than I do is agreeing with you. So,
No, R. You should learn R.
Yeah, I agree with that. Yeah.
There's just no question. But you'll find that if you have any programming chops at all, you'll want to process your data with Python.
I would think so. Yeah, yeah. So I think if there's an easy answer to the question, it's that in the corporate end of things, it's going to be Python. In the academic, it's going to be R. But there's crossover on that. Really learn both, right? Like, but R is just funky. I mean, to me, it's like if you don't have a programming background and you come to R, it's going to make sense. If you come from an object-oriented programming background, and R is object-oriented or can be, and it is functional or can be. It's not like a functional language, but it has functional ability in it, and but I think if you come to R with a clean slate, it's going to seem like a much better language than if you come to it with like C++ or Java background. And then people like me, and I'm not a big developer. I've never worked like as a full-time engineer. I've worked doing development, but not for years and years. But to me, R is just like it's a little weird. I don't know. Yeah, please.
So you can almost make a comparison between, like, say, Bash shell scripting.
Okay, yeah.
And doing something in Python. You can do stuff with Bash.
That's true.
It's really convenient. It's quick. It's easy, right?
Yeah.
But if you ever write anything meaningful in Bash, you'll hate yourself.
Yeah, and then Bash doesn't have, like, if you're really doing applications development, Bash doesn't have a graphics library. It doesn't have.
Compared to writing a Python script that will go do stuff. Right?
That's true. Yeah, that's a good point.
Python script takes you a little bit more time. It's not something you just grab at the command line when you're wanting to count words or something like that.
Yeah.
But both of them are incredibly valuable.
And I think for the data science end, people aren't so much developing. They're not developing web applications necessarily. They're not, developing applications in that sense. You're typically just going to be writing scripts to process data. Like when I worked at Huntsman, I was a computer guy. I worked around all these really smart genetics people. I was working on a genetics research project, and they had a process that took too long on one computer, so we were moving it over to Apache Spark and putting it on a cluster. But I didn't learn more than this about genetics, right? Like, but the people that knew genetics, they tended to just do something once and then throw it away. They didn't tend to build a library of Python scripts that they were using over time. They tended to analyze some data and then move on to the next project. So I think I think the data science answer to the question is probably no both. but I appreciate. And what's your name there in the middle? I'm sorry.
Mine?
Yeah.
Robert.
Robert. Okay, yeah. So I think Robert's probably got more experience with this, so I would talk to him after this and pick his brain a little more.
Learn both.
Yeah, learn both. Yeah.
And then use whichever one makes you happy.
But put Python above R on your resume if you're applying for a corporate job, And if you're applying for a PhD program, put R first. So, okay, so let me kind of blow through the rest of these slides here. I think, yeah. Okay, there you go. And I think, yeah, it just depends on where you're applying. So I actually just wanted to talk about this. Everybody's seen this graphic before. It seems like it's like required. If you're gonna, I'm gonna talk about this for 1 minute and move on. This is like, if everybody's seen this graphic before, or if you have seen it, raise your hand. Oh, I'm surprised. Okay, I thought this was pretty much. This is like some guy in 2010. He wrote this thing about data science, and he's saying, there's these 3 different areas of knowledge, and if you ever make a presentation on data science, I think you're required to put this graphic in. But the reason I wanted to bring it up is because of what's missing. Like, you have hacking skills, you have math and stats knowledge, you have substantive expertise. I guess that's the chemical engineers or the petroleum engineers. But they don't really talk about developer skills. And I think that all I wanted to say about this is that when people just have hacking skills, like that doesn't mean hacking like breaking into your computer. Hacking is something like, can you Google some stuff? Can you keep on trying things? Like, can you teach yourself how to solve a problem independently? I think some of what hacking skills mean. But what's left out of that equation is like some of the things I think that we could focus on in future meetings is GitHub. And different answer to your name. I'm sorry, John. So we were working before the meeting, trying to figure out his Windows environment and trying to bring this project down. And I think those are skills that, like, if you don't have any of those skills, you're going to be worse off. And it's great to have all of these crossovers, but it's an actual like developer skills, like understanding, how to build a. Like, it's great to have some code, but to actually integrate it with somebody else's code and then, work together with a repository like Git, and to make sure you're not breaking each other's code. If anybody's ever done Java, or all languages have continuous integration, right? Like the idea of, is there any DevOps type people in here? Anybody have any DevOps background? Yeah. So there's this idea that if you have a work group of people and they're all changing their code, well, you can like wait and just try to integrate the code every 2 weeks, which is how they used to do it 20 years ago. And then you find, oh, I just broke somebody else's code, and then you spend all your time. And what people do these days, and maybe not so much with data science, but if you get around any development environments, you'll find this concept of continuous integration, where like almost every time you commit a change, just things like Jenkins is one. What's the other one called? I forget the name. There's another system that's kind of competitive with Jenkins, but anyways, it's a system. What is it? Sorry, I can't hear. Hudson. Well, no, I think Hudson's the old name for Jenkins.
Yeah, Hudson's a split off.
Oh, is it? Okay. Yeah, and there's something else I'm trying to think of, and I can't think of it now. But anyways, you'll find that every time you check in, like when we're using Git, when you make changes, you're going to commit and then push your changes to the central repo. And if you break something, these modern systems will right away, your manager and you will get an email saying you just broke the build. You're like the bad guy. You just made the tree red. And so if what I just explained in the last 2 minutes doesn't make any sense, then it's something that I think that everybody should have at least a basic understanding of the developer environment. So I just disagree with this. When they say hacking skills, I think it should actually say developer skills, including hacking. But you might just, if you're just going to be like if you are. Yeah, I mean, I think that's what they're getting at, is problem-solving skills in general. And to me, that really goes back to, can you look stuff up on Google? Are you active on Stack Overflow? I find, like John and I were trying to look something up in the documentation, and a lot of times you just go to Stack Overflow and go through a couple of questions and find your answer a lot faster. And so, okay, so bottom line, this is what I'm saying. Bottom line, don't overlook development skills. Now, for people that are traditional developers, when you build software, you would work in your IDE, whether it's Eclipse or IntelliJ, and you would work on some application. And then with data science, part of this hacking skills is that you're actually, instead of trying to work out some code and then see if it works later, you can actually just try things out on the command line. We'll take a look at this. We'll bring up either Pycharm or Spider and show you how you can just try things out on the command line. Jupyter Notebooks are good for that. So the nice thing about R and Python and other.
Did you go over Jupyter Notebooks? I missed that part.
Yeah, no, yeah. I'm actually just trying to blow through these slides in the next couple of minutes, and then we're going to get into some demos. So basically, you can try things out. It's called iterative programming, or they call them REPLs. So I have that up there. Read, eval, print loops. So if you're trying to write some code and you're trying to figure out what function to use, you can actually try it out. Like live right in front of you and see if it works. You don't have to build it into your project, try to compile the whole thing, and dig through some horrendous error message. So this is the, again, for people that come from more of a traditional developer background, this is what's changing things about Python. Now what I'm saying has been around for 20 years, right? Like Python, I think goes back to the early 2000s or even the late 90s, but it's just as relevant today. And if you're just coming to it for the first time, this is something to learn. What did I say at the end there? Oh yeah. So I'm just going to mention this real quick, and then we're going to jump into the notebooks.
You mean like the apply functions as in iterative functionality in like Arg and stuff like that?
Well, when I say iterative, I just mean using the shell, like using the interpreter. Like where instead of like writing a script and then running the whole script, you can just like try things out in the environment, like on the fly.
Oh yeah, you mean like using like RStudio then, or do you just
using what now?
You mean like using RStudio?
Well, but even more than RStudio, in RStudio you have the REPL. It's the. I'll actually show it in a minute here. So instead of trying to take a minute to describe it, we'll just show it. But I thought you were asking at the bottom there. This is something else that we're not going to get into today. But when you're using Pandas specifically, if you're ever writing a for loop, like when I was in this class up at University of Utah, they were bringing a lot of people in master's programs in that weren't programmers. And there was very little emphasis on programming skill or even like how to do things correctly. It was just more if you could just get the assignment done, you're good. But I learned later on that in Pandas, like if you're writing a for loop, you're doing something wrong. And this is specific to Pandas. Pandas puts data into a data frame. We'll look at how this works pretty soon here. But when you're actually processing data in Pandas, everything is written. Now, when you mention apply, apply is one function that you can use on Pandas. It'll apply it, and Pandas will actually figure out how to spread that across multiple processors. If you're in, now I'm not talking about clusters, I'm not talking about multiple computers, but if you have like an 8-core or a 4-core, or like even this is an old, now it's old, right? It's an i5 dual core. If I run a for loop, that for loop is only going to execute on one processor. But Pandas is written to be multi-processor aware. So this is just a point I'm bringing up in concept right now, and we'll see if we get a good example of it or not. But it's just something I chose to throw on the slide there. Now let me just look at this real quick here. I mean, let's actually, I mean, we can go back to the slides if we get time, but let's actually take a look at some notebooks here. So give me just a minute here, and if anybody wants to make a comment or has a question, let me know. Let me switch what I'm presenting here. Application window. Let's see if I got the right. Okay, and then what I need to do here is to bring up. Now, if you can watch my Hangout back there, Ro, you should be seeing. Let me know if you're seeing that window. Not yet. Okay, let's see. Is it a different window?
It's the logo with black background.
Oh, you know what I have to do? I have to say present to everyone. There we go. Yeah. It's funny how, has anyone ever taken like Calculus 3 or linear algebra and you realize you forgot how to add? It's kind of the same thing here, like, oh.
So it's a little blurry. I'm just going to point out, if someone's looking at this and it's blurry,
yeah.
you need to change the settings in your YouTube to a higher quality. So default to 240.
Oh, is this broadcasting at 240?
It's on YouTube. I think it just maybe my computer, but it's small print relative to the screen.
Yeah.
It's blurry, but if you up the quality to HD, it's perfect.
Let me see if you can, let's see, I got it down on this screen. Let me bring this up to the big screen here. Sorry, we're just going to take a minute to try to improve this because I do want this to show up well for people.
It looks great now.
Does it?
On YouTube, it looks fine, as long as someone knows that on their end they need to change this.
Oh, on their end. Okay, so the comment coming from Ro in the audience is that if you're watching this and it's looking blurry, it's actually should be being broadcast in full HD.
You have the option.
Okay, yeah. So you're seeing full HD as an option.
I'm seeing it now after I've made the change.
Okay, cool. So just make sure you change your resolution on your browser to the full HD or whatever the best you can get is. Okay, cool. So let's take a look here. Just for the people here, I'm going to let you see. I'm going to bring up. So I have this meetup, this repository that I set up. You can grab all these files if you want to look at these. So the basic way you run a Jupyter Notebook. I mean, there's a couple different ways to do it. When I'm on the command line here, I tend to actually like type in the name of the file that I want to run. So like pandas examples, this will actually bring up the file directly. What I've seen, but I tend to come from, I was working with Unix back in 1990, so I tend to be more comfortable in the command line. But what I've seen people do, and now you're seeing that on your screen now, Bo?
Yep.
Okay, good. But you shouldn't be seeing this. Sorry if people at home aren't seeing the commands I'm typing here. What I've also seen people do is just type in Jupyter Notebook, or as we saw in the Windows environment, it's an application you run, and it brings up the navigator. And what, if I could just type, what this does, when you just type notebook without a file name, it'll actually just bring up a browser, right? So you can actually go through your file system and then click on the file. People tend to like to do this more. It's just a personal preference. So I just want to go into these examples first here. So is there anybody, people here, let me just ask it this way. Who has seen notebooks before or worked in notebooks before? Okay, so we're seeing some people that maybe this is the first time that you've ever seen a Jupyter Notebook. So the whole point of a notebook is to have, I think maybe this came out of the data science and the academic side of things, where you want to present, if you want to present a report, go ahead, please.
Well, the other thing is it allows them to set things up in a way that's repeatable for an experiment or something like that, so that people understand, this is what I was doing, this is how I cleaned the data, these are the steps I took, and then someone else can follow that.
No, that's a really good point. I appreciate that, because I was going to overlook that point. Part of what you can do with this presentation format, what she's saying is that you can set up a series of steps and a way of analyzing data, and then we're not going to get into how you would publish this on the web today. There's ways to do it. There's even ways to do it where multiple users can all contribute at once. You'd have to set it up for SSL. You have to make it secure. It's a lot more complicated. But the basic idea is that you could send this notebook with the supporting data files, and somebody could repeat your experiment. To me, the main thing that's pretty cool about it is that you can actually get in here, and let me make this a little bigger. To me, the thing that's cool about this is that you can actually get in here and you can write Python and by extension Pandas, and you don't have to worry about debuggers. You don't have to worry about IDEs, development environments. You can just get right in here. What I don't like about it so much is that it doesn't give you this REPL idea, which I'll look at that in about 2 or 3 minutes, and get back to your question. What was your name up in the front right there?
My name is Jubal.
Jubal, okay, cool. So Jubal's question, we're going to get to and show you how you can write things. You can write things interactively here. For example, I can actually just go in here and say, let's make a new cell. So I'm kind of contradicting myself here, but I like the REPLs for different things, and I'll show that in a minute. If I say insert, here we go, under the insert menu, if I say insert cell below, and then, the simplest thing you can do in Python is print, hello, I like to spell it world. I don't know. And if you just hit Control Enter, then it does it, right? Like if you've never written any Python code before, bring up a Jupyter Notebook, create a cell and just print something, and hey, you've actually written some Python. So that's the first step that everybody does in any kind of language. Now, I'm going to show Spider real quick here, or actually, let's just look at Pycharm instead. Let me bring it up. Now, can people just mention real quick, do people use Pycharm or Spider, or they have their own favorite development environment? What do you have?
I like to use
Pycharm, okay, cool. Yeah, and if you're a student, if you have a .edu email address, you can get a free subscription for 1 year at a time and get all their professional products for free. And then they have community editions too, which are pretty full-featured. So I don't think I'm doing anything that requires the professional stuff, but hey, it's always cool to get free stuff, right? Does anybody use Spider?
I tried Spider. I wasn't super impressed. Given I'm one of those idiots that you would describe as someone without a computer science background.
Okay, cool, right on. Well, that's actually exactly who Python is designed for. Maybe more our discussion I think we had before you came in, but yeah, this is, a lot of people are coming to it. You don't, as these tools get better and better, you don't need a computer science background to do this kind of stuff. In fact, it might, in some ways, might get in the way. You might overthink things if you have a computer science background, but that's sort of a different debate. Let me broadcast this. I'm sorry? Oh yeah. Just,
Vim, you get like a million hotkeys and stuff.
yeah, and it's kind of funny with Vim. I was a VI guy. I still bring up VI just as a basic editor. I've never learned Vim. I use Emacs actually, but my boss when I worked at University of Utah forced me to learn Emacs, and so I think, you know, on one hand I like bosses that let you use whatever tools you want to use, but I think it was good to learn. Let me just show Pycharm here, and I want to just give you kind of an idea of this REPL thing, and then we'll jump back into the notebook. Sorry, here we go. Oh, is that right? Oh, no kidding.
The plugins that they have available through JetBrains, they have one for
Okay, so you notice here, and I mean, Spider's going to have something like this too, but you notice it's probably a little hard to read, but it says Python console down there. Now, I mean, basic installations of Python come with idle. Come on now. There we go. So, I mean, it's going to come up here, and this is actually a notebook style console. Let me see, is it going to give me a way to do? No. I mean, but it's the same thing here. You know, if you just want to test something out, I mean, lacking a better example, you know, I'm just going to do the same thing where it's a print statement, and it just, you can just test things out iteratively. I mean, the whole it's a REPL is the term, REPL, read, evaluate, print loop. I think that's what it means. And it just lets you, instead of trying to do something in your program and then run the whole program, if you just need to figure out some syntax real quick, you can just test things out on the fly. Now, if C++ ever gave you something like this, I'm not aware of it. You know, this is to me, on a very basic level, one of the big differences with data science and things like Python and R, you know, versus developing in more traditional languages, is that, you know, more traditional languages, you're going to sort of plan everything out and build this big block of code and then see if it builds or see if it compiles. Here, you're just going to try things out iteratively. And that's the mindset that you're going to be in when you're working with data science type of things, you know, which includes machine learning. It includes a lot of different fields. So unless anybody had questions about Pycharm, you know, Pycharm, it does let you look, like we're going to look at this in Jupyter Notebook or probably within Pycharm later. This is a little more complicated Jupyter Notebook. So I'll probably try to get to that about 10 minutes before we're done here. But let's go back and take a look at this basic. And then let me just, bear with me to share this. Oh, come on now. Linux is really having a little bit of fun here today. Okay. Application. Okay, so should be showing that. Should be showing us on the screen now. If you look in here, the first thing that you do, you know, this is just really basic. And when you're looking at a Jupyter Notebook, you're working in steps. So each cell, you know, what is the very first cell just imports pandas. Now, can everybody read that, or do I need to make that bigger? Is that? Well, yeah, you're like younger in the back row there. Of course you can read it. I'm asking people like, I'm like 32 right now. I'm just kidding. I'm almost 50. But you know, if anybody can't read that, throw your hand up and I'll magnify it. Okay. Okay. So your very first cell needs to run. You need to import pandas before you're going to use pandas in a later cell. So if you're in, sometimes people open up notebooks, and you know they come down here and they try to run something down here, and they're, you know, I don't think I ran. Yeah, I didn't run all the cells. So if you look at what's happening here, it's trying to do something called pd.series on this. You know, we made this list here called numbers. If anybody's familiar with this in Python, when you put something in brackets like that, it's a list. And so this is like the most basic thing in pandas. You know, like you're making a list in Python, and then you're creating a Pandas series out of that list, but it doesn't work. It's saying, I don't know what PD is. Well, the point that I'm getting at here is that when you're running a notebook, you have to run things in steps. So, you know, one thing you can do is just come in and say run all cells, like under the cell menu here, you have run all, but I'm actually going to do this iteratively. And different people have different styles. I mean, there's people that like to use the menus. I tend to just click in a cell and hit Control Enter, which runs it. But you can also just go up here and on the cell menu you can say, you know, run this cell, run everything below, run everything above. but I'm just going to do this sort of the manual way. So when I run this cell, there's no output, right? It's, what is it saying here? Oh, you know what? Okay, and I'm not sure why, this is probably a really dumb question for me to ask, but I'm not sure why I'm getting this output. What's going on there?
So you've got p.series and a question mark?
Yeah, oh, is the question marks doing that?
Yeah, question mark
Yes.
plus the documentation.
Thank you. Okay, cool. This is actually an example given by a Coursera course. I didn't write this stuff. So that's actually bringing up the documentation on it. Okay, cool. Thanks.
And then the Ipython interpreter did that too.
Okay, cool. I didn't realize that was what was going on. Thanks. I knew when I tried this earlier, I wasn't going to spend the time to figure it out because I was just trying to get like the AV stuff to work, but I knew somebody would be able to answer that. And it's worth mentioning without getting in detail today that Python, what do they call it, magic? There's all these magic functions in Jupyter Notebooks. Or when people say Ipython is what it was originally called. These notebooks were originally just for Python. And then people started, developing ways to show R, to show other different languages. So now I forget how many languages. So they renamed the project Jupyter. And you mentioned it still has the PY in it, like it's Julia.
They said that it came up because they were combining Julia, Python, and R, which were the languages.
Oh, the language Julia. Okay, so that's Jupyter. It's Julia, Python, and R. Okay, cool. They'll learn something new every day here. So they renamed Ipython to Jupyter. So you'll see under the hood a lot of the stuff, like the files are still called .ipynb files. That's an Ipython notebook, but it's really a Jupyter notebook. It's really not just a Python thing. But like I said, we're pretty focused on Python today. So when you look at these, let's just go back up to the top here. In fact, I want to actually switch over to something a little more complicated. Let me go. Now I'm going to just use the menus for fun here. I think this was it here. So this is from this Coursera course. And again, if people are just we have very different skill levels in the room. For the people that are just still getting introduced to this, you can look at this. I actually have a link to this Introduction to Data Science in Python course. Like I said, I went to this because I was pretty rusty, and I think that if you're just coming to this fresh, these courses can be pretty challenging. If you have programming background or if you're just rusty, you can get through them pretty quickly. But this is actually one of the homeworks. So don't cheat and copy my answers. But you can see here's that same. That's funny. I guess when the kids are running around upstairs, it actually shakes the screen. This is an old building. You can see this is the ubiquitous import pandas as PD. And then here's a function I wanted to make sure everybody is exposed to. This pd.read_csv. A lot of times when you look on Stack Overflow or you look at examples, people are making like just example data frames on the fly, or they'll just build a list. We saw the other example where they just built a list and then made a pandas series out of it. A lot of times in the real world, you're going to be reading data from files. If you get a little fancier, you connect to streams coming in, but we're not looking at anything like that today. But there's this comma-separated value file out there in the folder or the directory, and we're using this pandas.read csv command, and then it assigns it to a variable called df. I mean, that seems to be like the default thing that everybody calls their data frame as a df. And then you can see, and again, anytime people have questions, just jump in, but you can see here where, let me just see if I can scroll down to where we can actually see the, okay, so this is what the data frame actually looks like when it's done. It's reading these, this is data off a Wikipedia page about the results, like how many people won like gold, silver, and bronze medals in Olympics, and by country. And so you notice what's going on here. It's you bring in the data, but initially the column names in the actual file are a lot more cryptic. So I'm kind of just showing you these examples of a basic workflow. You're gonna bring a file in, and then you're gonna actually rename some of the columns and make them. When you refer to the columns later in your code, if the column is like this long, you don't want to have to type that every time. You just want something a little more concise. So you notice that they're actually going through and renaming columns. This is like the number. I forget exactly, but this gold is like the number of summer medals, I think, and gold.1 is the number of winter medals, and gold.2 is the total of those two, I think. And you notice there's a field in there called totals that we don't want, so you can actually do a drop. I mean, this is the basic thing that I want people to see if they're not familiar with this stuff. And I guess object-oriented programming means different things to different people, but to me, one of the features of it is that once you create an object, once you have your data structure set up, then you actually just, like, everything is tied to it. There's a function called head, there's a function called drop. So you're just going to say df.head, df.sum, df.mean, median, mode, different functions that you want to run. And so this head function is something that you'll get used to as you're working on notebooks. You want to see what your data frame is looking like, but you don't want to look at all 162 lines or whatever it is. So you just do a head. The default is, I thought it was 4, but I guess the default is 5. And this is the iterative way. Instead of having to have everything all figured out. I'm just going to kind of bring this up one more time. But if you think to the really old days, I'm old enough that I've had like computer science professors in the 80s. I took Pascal. If anyone's ever heard of Pascal, I used to go to Foothill College out in Los Altos Hills, California, when I was like 18, 20 years old. And I had this teacher. He's up there and saying, "I remember the days when we used to use the name's escaping me, right? The paper punch cards, right? Yeah." And so, like think about this. I just want to go high level for a second here. Think about developing with punch cards. Okay, you've got like a mainframe. You only get to maybe run your job once a day. Or I think students went through this too, early computer science programs. They would actually be putting their code on punch cards. There's no debuggers. You really had to think about your program and make sure everything was right, because you probably only got to run your program once a day, and then you get your results, and you can't actually change something and try it again until the next day. And if you're lucky, maybe you get 3 chances a day if you work for some big company that owns some mainframe or something. But this is where things have come. I mean, it's come from where people really had to think about what they were doing and really plan things out, because you couldn't afford to have mistakes, at least not stupid mistakes, because it would cost you too much development time. Now you can afford to have stupid mistakes. You can just try something, and if it doesn't work, like, oh, I'm not getting the right column name, so let me just go fix it. So for people that like are developers or that have some time in this in this field, you understand what I just said. If you are new to this, then just really realize how easy everything is now, and it's only going to get easier. The kind of tools that are out there. I mean, if you were around 20 years ago trying to build a website, it was a lot more complicated. Now you just go to Wix or you go to Bluehost and get some builder and build a website, right? Maybe that doesn't cover everything, but okay. So, and is there any questions at this point on what you're seeing here? Okay. And again, I'll be here. We got about 13 more minutes on this presentation, and so I kind of want to get into this next notebook here and show you. I mean, this is pretty basic stuff, right? We're building this data frame. What's the question here? What is the first country? Okay, so I mean, this class starts out with some pretty basic questions, right? It's basically just saying, what is the first country? Let me see, what am I doing here? So I'm basically I'm using the head function, right? I mean, this is like really so simple. It's just basically saying, what is the first country in your data frame? Well, you can just run a head command and just give me the first line of the data frame, and then there I've got the first country. And then squeeze does a good job of, it actually finally returns this. Ultimately, I'm just printing out this return value that gets returned, and this is the actual first line of the file is Afghanistan. So you can do really basic stuff. You can get a lot more complicated. This course, this is like week 2. So then they start asking more complicated questions. And who's done SQL in here? Does anybody have background? Okay, I got more hands on SQL. Ultimately, what Pandas is doing is it's giving you the exact same interface to data that SQL does. You're selecting, from a table, like from a certain set of rows or from a column, and you're giving parameters on that data. You can say, like, which country has won the most gold medals in summer games? Well, there's this function here called Arg Max. So instead of writing a for loop, like what's the old way of doing this? You write a for loop, and you say, okay, you make your first value your maximum value, and then every successive value you compare to that and see if it's higher. And if it's higher, you make that your new maximum. And then when you're done, you return that as your maximum. That's like the manual way to do this. With Pandas, if you're writing for loops or you're writing, like before you start writing any code that really does any thinking, you look and see if there's an existing function. And Arg Max is a function that's going to say, give us, it actually returns you the index. It looks through the data frame in the list of gold medals. It finds a line that has the highest value. And if you just wanted that highest value, like tell me how many medals the highest winning country was, you would just use max. But if you want the index, like on the left side, you notice all the different names of the countries. That's called an index. And if you need that, you use Arg Max instead. So I mean, it's just really simple. You just say, look at the gold medal column in the data frame, and give me the index of the max value, and you can see right there, it's it's the United States, which I thought maybe it was going to be Russia, or if you went for the Winter Olympics, you'd probably be looking at Austria or some country with. We have great skiing here, obviously, but I don't know if we can compete with Zermatt. So. I'm sorry.
Guess we'll find out in a few months.
Yeah, no kidding. Well, last year was a pretty good. 2 skis in here. I don't ski. I've also never broken my leg. I would like to go see if there's still snow in Timpanogos. If anybody noticed, there's still a little patch of snow on the face. So if anybody actually hikes up the backside, there should be some good snow up there. So then this lesson here, and we're going to leave this page in a second, but it gets into more complicated questions. Figure out what's the ratio of which country has the biggest difference between their summer versus winter gold medals, relative to their total. So this is starting to sound like an SQL query, right? But here, if you look at how I'm doing it, I'm basically saying, I'm actually making a new data frame. I'm basically saying, show me ones, where the gold is greater, the summer gold is greater than the winter gold. I'm sorry, show me the ones where this and sign is the operative thing. So show me, because if you notice, sorry, I'm jumping around here, but notice what the question is asking. Only include countries that have at least one gold. So I'm saying, show me, make a new data frame that has all the gold winners greater than 0 and all the winter gold winners greater than 0. So that's like a basic programming statement that says if these are not both met, then don't put it in the new data frame. And then what I'm returning is the new data frame, gold, minus the winter golds, and I'm dividing it by the total. That might be a bug actually, but because I think I'm actually dividing it by the summer gold. I don't know how I got this right, but that's actually a bug. That should be gold.2. And then give me the country name again, Arg Max instead of Max. And the end, yeah, in fact, this must be an older version of this because it's not Bulgaria. So basically, you can kind of see, a lot of people are from an SQL world, and that's one way to deal with things. But this is in the data science world. I don't think there's a lot of people, like, you should know SQL just to know it, but I don't think there's a lot of SQL used in the data science world. I think it's going to be a lot more Python, Pandas. Even with R, you're working with the concept of data frames. In fact, I think R, yes, please?
Well, I was thinking, it depends on what sort of position you get yourself into, right?
Yeah, true, right.
If you're using the data you have access to is all in a database, then you're probably going to need NoSQL in order just in order to get it out of the database so you can work with it.
Yeah, or you might actually use a built-in function in Pandas to connect through a driver to a database and just read it straight into a data frame.
Sure.
Right? Yeah, and I think that's built into Pandas. I haven't done that, but and the point, and sometimes I think you came in a little later, but because this is also on a Hangout that we're recording, I'm just repeating the questions for people watching later. But the point being made is that there are situations where you need to know SQL. But I think when we generalize in a vague way and talk about data science, it's a lot more about R data frames and Python data frames than it would be about about direct access to a relational database. But you're right. There's going to be cases where you need to know that. In fact, we were talking before we started about different master's programs in data science, and like Western Governors has this online program in data analytics, which seems to focus more on SQL and like SAS and SPSS. Doesn't really seem to have a machine learning segment. And then there was another program we talked about at Georgia Tech that I'm actually looking at getting into. You could do a master's program for $6,000 online. And it seems to focus more on machine learning. If anybody knows about that program, tell me about it afterwards. But basically, I think, like the discussion we had earlier about R versus Python or data science versus like Python, Pandas versus SQL. Yeah, your point back there in the back row is very well taken. What's your name back there? I'm sorry.
I'm Tanner.
Tanner? Oh, you're Tanner. Cool. Okay. Yeah. Hey. Yeah. I mean, different environments are different. But if I was applying in general, if I had like a single data science resume, kind of like a joke, I think before you came in, I would put, if it's to a corporate, I would put Python before R, and if it's to an academic position, I'd put R first. But I think I'd put SQL last, if I only had to have one resume for data science, right? But depending on where you're applying to, right? I mean, obviously you tailor your resume, but I think the SQL skills are probably less important if you have to just learn one thing or the other. Having said that, SQL is all over the place, but In fact, just to say real quick, if you've heard of these NoSQL databases, they're not. It doesn't really mean NoSQL. It means not only SQL. So if you ever hear that term, just realize there's SQL interfaces for them. So what I want to do now is I want to bring up another. I'm going to switch out to my terminal here for a second. One thing I'll just mention super quick, and if it's okay with people, I'm probably going to go a little past 3. I mean, the presentation was only planned between 2 and 3, but I'd like to spend more time in this next notebook. And so does anybody have a hard deadline to get out of here right at 3? Okay, we'll probably go like an extra 10 minutes then. And then we'll spend the rest of the hour if anybody has like offline questions, or we could look more at your configuration and try to get that figured out, John. Okay, so I was just going to mention, like when you're running in Linux, people tend to just, if they're not familiar with Linux, the first terminal you bring up and you run stuff out of, you're going to get all these sort of junky messages in, and they're not junky if you actually need to look at them, but generally speaking, like who cares that your Jupyter Notebook got saved every 5 minutes, or what is it, well, actually more often than that. I guess every time it sees a change, it tends to save it pretty quickly. But what you tend to do is you tend to run, like this is like your terminal or your console, you tend to run certain things out of here, but then if you're doing other terminal work, you bring up a second window and do it there, so it doesn't get cluttered up with a bunch of unexpected text. But I'm going to go Jupyter. Oh. So in this repo that we have, which is on GitHub, there's a folder in there called UDS. It's this data science class I took at University of Utah. Really good class. It was the first time they taught it. So let me just bring this up here. So again, Jupyter Notebook, and then I'm just going to give the file name explicitly, and you'll see it should pop up. There we go. And this should be showing, if you just, last time I'll have you check the Hangout row is make sure that new page is showing up with the real estate data.
It lags about 30 seconds.
Oh, really? That much?
It's been consistently showing up.
Okay, good. Cool. All right. Well, thank you. Cool. So I took this class, and I don't know if anybody is going to be going to university. No one's here is a University of Utah student, are they? Good. Okay. Because I mean, they actually have this course online, so I'm not like giving away any secrets. These assignments, if you look, are at this link here, U of U Data Science course. It's actually pretty cool to look through here. You can look at their repos. You can look at the syllabus. They taught this once. I don't know that they're going to teach it again. It's not listed for this fall, or we'll see what happens. But it's kind of a challenge, because what they tried to do is they tried to have a class based on Harvard. There's a Harvard class called CS 109. And so that's data science. When you take that class, you have to have statistics, and you have to have at least one programming class. Somehow at U of U, they didn't make it quite as tough, but they also didn't have any requirements. And they listed it for both undergrad and grads in the math and computer science catalog. And it was specifically intended for non-computer science majors to come in. In my opinion, the assumption that you're just going to come in and do a class like this without any programming background, yeah, if you want to spend 40 hours a week on one class, which some people in the class were doing that, then go for it, right? But before you try to do any like actual data science classes specifically, make sure you have some programming background. Even if it's just taking some intro to Python. There's a great series on Coursera's, not even the data science series, just it's called Python for Everybody or Python for Everyone. Do you know what I'm talking about?
There's also a free book by Alan P. Downing called Think Python.
Okay, yeah, books are great too. Yeah, and so books can be helpful too. But sometimes people, I don't know, sometimes the structure of a course is nice. So you find on Coursera there's this Python for Everybody class. You do web scraping in that class. You connect to a database. You actually get like fairly simple exposure to fairly complicated concepts. So it's a good way to get your feet wet. So I'm bringing this up to just say that there's a lot of different data science courses out there. So this actually comes from the University of Utah data science course. And again, you can look up in the link here and get all the materials. Or if you really want to be challenged, go look at the Harvard CS 109 course that it's based on. I think if you're already getting into Harvard, you're probably smarter than the average person in the first place, and so the standards are higher. So, but basically, you see the same thing here. You see import pandas as PD. Then there's also something else that we could do a whole presentation just on. Syfy is in the Anaconda distribution. It's one of the packages. It stands for Scientific Python. So some of the assignments in here are just like setting up data frames, but then doing statistical analysis on them, doing like regression analysis. So I'm going to take the next 10 minutes and run through this, and then we'll wrap up. You notice here there's also this line here, import matplotlib as PLT. I'll just mention real quick, and if somebody knows better than me on this, because I never took the time to figure this out, just tell me afterwards. But you'll notice sometimes I re-import this later on. I don't know if we'll get to that level of detail, but I'll re-import it under a different name because it looks to me like matplotlib sets up some kind of environment. And then if you're trying to go make a different graph, like I don't know if those two environments step on each other. And I never went back and tried to figure this out. So if anybody's like a matplotlib expert, then catch me after we wrap up here, and I'd sure like to know if I really needed to re-import it or not. And then ggplot is actually from the R world, but we use ggplot in here. There's a Python. See, a lot of the cool stuff that you can do in R has been brought over to Python as well. So there really is a lot of crossover, and I think it's a fair statement to say anything you can do in Python, you can do in R, probably almost without exception. If anybody has anything to disprove that, I'd like to hear it. But I'm partial to Python. So this is the thing that, there's sort of a standard saying. A lot of you have probably heard this. The idea of cleaning your data. Like a lot of the data you get in a big database or a CSV file, if it comes from a relational database that enforces a schema, relational databases are very strict about how you can put data in the first place. So data tends to come out pretty cleanly, but when you don't get it from a relational database, it tends to be all over the map. You can have, some of your data is bad. Maybe there's like some header information that you have to ignore. There's always, you don't just ever, you almost never just suck a file into a data frame without thinking about how you're doing it. So there's sort of the standard saying in data science that you spend 80% of your time cleaning, munging, I guess is another word for it. What's that? Janitorial. I like that. That's what it is. Yeah, I never heard that term applied to it, but that's exactly what it is. So you'll find, and on Coursera, there's a series of classes on R that are very good at teaching this skill. So here you're given a spec, right? You're being told there's 206 different variables, and there's 348 houses in this data set. What this data set is, it's house sales information. If anybody knows the neighborhood, what's it called? Federal. It's the neighborhood just north of the university, like the avenues, right? The avenues.
Federal Heights.
What is it? Federal Heights? Yeah, so if you look at the avenues in Federal Heights, just like the north of downtown Salt Lake City, this is sales price data for that neighborhood. So initially you're coming in with 206 different variables, but we probably only care about 20 or less. So when we first bring it in, we're gonna actually just, I think the way I did it here, if you look, I think I'm actually giving a list here. Where's my scroll bar? Oh, sorry. Yeah, now these lines go on a lot further. Like if we could see the whole line, it probably goes over here. But when I first do the read CSV on this, I'm actually, you have to specify certain things. You have to specify, although it may have been a default, but you notice I'm specifying a comma as thousands. And then I'm telling it which columns to use. So a lot of times you'll see projects that bring in all the columns and then drop them later. My approach is why bring in stuff you're not going to need. Like I tend to go into these asides, and I've got to make a quick aside that, in the old days, like long before I ever started. Well, actually, when I started, I was working with Apple IIs, right? And the first computer I had was a Mac that had 128K of RAM. Right? Now you've got like billions of times that much memory. I mean, I had a friend that had an Apple II that had 64K of RAM and 2 floppy disk drives, and that was really cool. And when you program in that environment, you have to really care about your memory usage. You'll find in introductory data science classes, they don't stress that, but it's worth thinking about, right? Like there's this thing that you never optimize before you need to optimize, but I think that can be taken to an extreme. So my point, the reason I bring that up, that general concept, is because you'll notice I'm using use calls. I'm only bringing in the columns I want to use. Here, later on in the assignment, and we're not going to look at this today, there's a little bit of sort of machine learning going on where you're bringing in, like you're like splitting your data set into 2 different training data sets. But we're not going to actually look at that. Ultimately, what happens here is you're given 2 different CSV files, train 1 and train 2. and then we're actually putting those together. And so this is different than merging. Merging is something we can look at in a future meetup. It gets pretty interesting. But this concat function just takes, if you have one data frame and another data frame, it just puts them together like this. If you've got 100 houses in the first data frame and 200 houses in the second data frame, it just makes a 300 row data frame. So that's what we ended up with. And then at the end, I'm actually doing this printing out. I'm making this data frame called home data with this concat function. After we bring in, these two, these two data frames. And then I'm just showing shape. This is something that is very good when you're doing your iterative programming and trying to figure out, I just made a data frame, did it come out the way I expected it to? You can just go on that REPL, that command line that I showed you, or just do it right in here and just look at the shape. And I can see, hey, look, I had one that was 200 by 18 and one that was 148 by 18. And then in the end, in the end, when I did the concat, I got one that was 348 by 18. So those are the kind of steps you can take along the way to just, and that's good because if something changes later on and breaks things, you'll catch it. Otherwise, you'll be like chasing down errors that don't make any sense. So, I mean, you can go through this, you can get this file and you can look through it, and in a Slack channel, if you have questions, let me know. The thing I really wanted to show you is a couple things. There's these, this scatter matrix. If anybody wanted to do a presentation in here, and I have a statistics background, but I've just never taken the time to really figure out like what do all these, my understanding of what this matrix is doing is it's actually showing, like, is anybody familiar with linear regression? Who's actually done linear regression? Okay, good, you guys in the back, cool. And then a couple people up here. So basically you're looking for, if you have two variables in the data, a linear regression says, is there a correlation between these two variables? So when you see like these there's probably not a whole lot of correlation. Like here, the next one up, you can see that you could lay a regression line. You can fit it to a line, and it's basically just checking. I mean, that's actually a pretty obvious one in real estate. This is list price, and that's total square feet. Does everybody think that the size of your house has something to do with what it sells for? That's probably your neighborhood and your square footage is probably your major determinant, right? Like, who cares if you have gold faucets? Anybody could put that in, but what this assignment ultimately does is it has you look at the different variables and do these correlations to try to figure out what variable is driving what variable. But the part that I really wanted to show you today that I think was kind of cool. Is this working? Let me do a run all here. And this is going to take a minute to come up here. But we were given sort of an extra credit part of it where you're supposed to overlay the data. The data would actually show you on a chart. You'll notice here I'm using something called Folium. John, we were looking at this before we started trying to install this package. What this is actually going to do is it's going to make a plot that, like, relative to where the house is physically located, and then if the house sold for more, it's going to make a bigger dot, and then we lay it over a map. And so the reason I wanted to wrap up with this, come on now. Let me see. There we go. Come on now. Let's see if I can. I'm trying to find my scroll bar here. Oh, there it is. Cool. And so I can zoom in on this a little bit, and I think this is pretty cool. I mean, it's not all that complicated in the big scheme of things, but for the level of what they were teaching in this class, this was pretty cool to be able to put this together. There's these open. This is actually using existing like online open maps. I didn't draw that map, but you can look and see. And I forget if I hover. I don't think it does anything when I hover. Let's see. Yeah, it actually shows when you click on each one. It actually shows you the sales price. So I kind of wanted to wrap up with this because I think it just shows. Like, it's one thing to import some data and then print it out and see some list of data, but graphics are always better. And so, if you were trying to develop an application that, like Zillow, I'm sure Zillow does something like this where it gives you some way of representing sales prices on a neighborhood. If you're going to go work on a job like that, you'd need to have these kind of skills. This is pretty rudimentary compared to what's happening in the real world. But I think if you want to learn how to do this, you would look through this. you can see I import this project here called Folium, or this package called Folium. I'm grabbing, for the colors, I'm actually making a set of data based on the sold price, so it knows what color to make it. The area, I think I'm doing it based on the acreage of the property, and so that's making it how big the dot's going to be. I'm actually setting up a latitude and longitude variable to say where the map is supposed to show. And then here I'm actually calling Folium. I'm saying map1 equals this Folium map. I'm giving it the latitude and longitude. Stamen terrain, I forget off the top of my head, that's like a map style. So that's not like a label or anything like that. And basically, I'm using a for loop. I normally say that's a bad thing, but in this class, they didn't really emphasize performance. They just wanted you to get it done. And so there's probably a better way to do this, like using an apply function. And then you end up with that map. And so I want to wrap up at this point, and I'm going to shut down the YouTube or Hangout part of this. And then we'll see if anybody has any kind of questions. Otherwise, we're basically done for the day. And I mean, just before I shut off the YouTube part, for anyone watching in the future or anybody here in the room, I just want to thank you. It's always hard to predict when you have 36 people signed up to show up, how many people are going to actually show. And for a nice Saturday afternoon, I'm very thankful for the people that did come. We got about, I guess, 18 people in here. And I'm glad we could all have a table to sit at and not have to stuff people in the back of the room. So thanks for coming out. And let me just shut this down and we'll take any more questions.
Thank you.
Oh, thank you. Get this to work here. There we go.